Hey everyone, we're going to look at number 9 in section 3.9. We're going to find the derivative of y equals the natural log of the quantity 3x plus 5 over x. So recall we have the derivative of the natural log function is just 1 over x. And with the chain rule, the derivative with respect to x of natural log of u, right, is 1 over u times du dx, or just u prime over u. So let's go with this one. Notice it's chain rule, right? U, the inner function, is 3x plus 5 over x. So the derivative of this function will be just u prime over u, where u is this stuff in the parentheses. So we literally get u prime over u for the derivative. Now, what is u prime here? Well, the derivative of 3x we know is 3, and the derivative of 5 over x is negative 5 over x squared. How did I get that? I hope you remember. 5 over x is the same as 5 times x to the negative 1 power. So the derivative by the power rule, bring the negative 1 down. I get negative 5x. Subtract 1 from negative 1 gives me negative 2. And x to the negative 2 is 1 over x squared. So I get negative 5, over x squared. So there's the derivative, but you can simplify this by clearing out these fractions within fractions. And the way I'm going to do that is multiply by the least common denominator of all my smaller fractions, right? So I've got x here, x squared here. So the least common denominator is just x squared. I'm going to multiply numerator and denominator by x squared. I'm multiplying by 1. I'm not changing the value of the expression. I have to be careful here. I need to distribute x squared over these two terms, and down here, same thing over these two terms. 3 times x squared is 3x squared. 5 divided by x squared times x squared is just 5. X squared times 3x is 3x cubed. 5 divided by x times x squared, one of the x's canceled, and I'm left with 5x. So that clears the smaller fractions out. We no longer have a compound or complex fraction. This is fine for my answer. I looked in Achieve and they have the x down here, the common factor of x factored out like this. And it's fine. Doesn't help simplify the problem any more. And that's a fine answer as well. So either one of these will do. Okay, neat little problem. Hope this is helpful.